I finally have got all the parts back and I've assembled it. It hasn't really turned out the way I wanted to turn out. So what I've done is looked up a few issues what I need to do. So I'll point the camera down to them and we'll go from there. Right, the issue is with this headstock. What I had to do is draw up a new headstock. I've got a picture here, I'll show you. And of course I've got a list of everything what I wanted done and highlighted what very important. And there's both pages, both sides, more paperwork. And how to make the shaft. See that there? And about the pulley. Now the pulley I got off the internet. To me they're going to be a problem. They've got a boss on them that connects to the shaft here, which is the 25mm shaft, and I had to get these port bosses incorporated into the build of the pulley. There it is there. And that's screwed in there, locked into position, and then it's locked down at this point here. So that gives a strong surface. So I had to do it on both of them, which gives me five speeds. But then I altered the pulley on the electric motor. It was a twin pulley, and I put a very small size on the other side. So I got virtually like a crawling speed, and I got good machining speed. So I thought that was alright, no worries, okay. And that seems to work very good, very good. I was very happy about that. So I set up the shaft and locked it. I'll show you. Because these angular bearings inside, I don't know if we can see that, can we? Get this around a little bit. Because there's angular bearings inside here, okay, they oppose the thrust from the machine. So what I did is I said, right, so if I put a bit of metal in there, when you're machining towards this way or towards the headstock, you should have enough support in this arm here, in this support column here, and this other one over here. But I asked the machinist, I would like to put it, I told him, I would like to put support, and he said, no, you don't need to put supports in there, that should be adequate. So with my drawing, I said, well, okay, you will weld it accordingly, and he said, yeah, he'll weld it as I depict on my picture, which I'll show you directly. So if you can see, yeah, you can see that there. So I've depicted this as the weld area, so you V that out and then weld it up. Because I did show in an original drawing that it was gusseted there, and he said I didn't need it. I'm regretting that I didn't push that now, because what happens, there is immense force when you're machining on the bearing surfaces, and what happens is it will only flex a little bit, but it's enough to cause a problem up this end here. Okay, so what happens is it will push back on this bearing. No, sorry, it won't push back, because the bearing is exposed on the side. What does happen is this bearing here floats out. Because it's an angular contact bearing, one side of the bearing doesn't have the surface like the other normal bearing, where you can have a little bit of side tension and all this with this particular type of ball bearing. So what happens is if you start trying to punch it out from the centre, the bearing from the centre race, the whole lot, only the centre race will fall out onto the ground and you'll lose everything. So I thought that was a bit of a mistake on their part that they done that there, because what happens is although I lock this up and take the tension up so there's no play on it, like there's no play on the moment in between that shaft. No, really. You lock it up. Once you get a little bit of tension coming forwards like this from the cutting tool, what it does, it causes this to flex loose because you're pushing that way and you're pushing back through the bearing because there's no angular contact this way, it's all that way. So I thought, well, what am I going to do here? Well, how it is set up at the moment, I have to return these to square position because obviously they've gone out of shape, because I'll show you something here. We'll get the little, this is a little gear set up, okay. They had made a spacer here for that to take up the slop so there wasn't any big gaps here. Well, that's the gap it's got now, and that's caused by those two there starting to pull in together. I'll be working it and all of a sudden lock up, and I said, oh, what's happening here? So if I'm using the tailstock and I got a live centre into an end of a bit of steel, it's putting pressure instantly onto the back end of this bearing. And believe you me, that there bearing on this side will tighten up because of the angles and all that of this. So what I've got to do is put a stiffener across there and put, first of all, put these gussets in here, gusset there, and I'll try and keep this area pretty clear because I want to put a special thing in there which I'll bring up later, as I will do. But other than that, it seems to go alright, but it has got a little bit of a tight spot. This is caused by that bearing being pushed over, so somehow it's developed a little tight spot on there. And what, you can probably hear that noise. I'll take that off, sorry, that's that making that noise. It gets a little bit of a tight spot there. And what that is caused by the angulation of the bearings and all that. Somehow probably the bearing is damaged. So I have to rectify that. Besides that, there's a few other little problems that we have with this lathe. Okay. Now with this setup on this, it's an ancient type setup. It's got you wind along like that, then you keep on winding along like that. Okay, that's alright so far. Okay, because you've got adjustment on the back here, and all of a sudden it starts getting tight. Now what that is caused by is there's wear on this surface here and this surface here. I don't know. Have I got? Yeah. We'll do it again. Wear on this surface here, which is on a V, and of course wear on this section because that's where that sits, just there and there. So we get a bit of tightness and all that. So that would cause a problem, and you know, all fixable. And I will be taking these on board just to get it back up to scratch. Now we've got another problem here. Come around this side here. Okay, we've got it here. Right. This is a gear train. And it's just what they call a simple gear train. You've got driver, and this idler. Off the idler, we come down to here. We go down to here, to another pulley. If that one, this one here is connected to that one there, okay, what happens it cuts about in one revolution 32 thou. So it can cut threads. This probably could cut threads and all that. So how do you reduce that? Well, you've got to use the idler, put a smaller pulley in there, which has got to be on a key. Okay, that's locked in there. See, key, and then you've got to get a key. A gear, which comes from there to there. Okay. So it's a pretty big gear. It's probably about that big. But obviously it has not, it's been lost or it's been damaged and thrown away. So I have to go and get another gear made up. 16 DP gear I've got to go and get made up, and with 88 teeth on it. These one here has got 65, this one's got 65, this one's got 60. We don't use that. Okay, we don't use that. We just use that as a spacer. That one there is a spacer. Got a key where it goes into there, and then another key, and then another gear goes. I'm just raving on here. And the other gear goes onto there. So I have to have this gear made up, which is, I think it worked out to be just a quicker. It's been a few days since I've had a look at this. It's about 155 mil, and it worked out 88 teeth. I don't know if that's the case, that they'll make the gear out so that it meshes out there, so that it's got to go from that small size to this big size here, which is 88 teeth, 155 mil in diameter. These here are only 4 inches, which is 100 mil. So we've got to go slightly bigger gear, another inch or so bigger, so it's about that size. Can you see that? Like that. And then we will get that machining. I'll let you listen to it. It's not the best of sounds, because we've got this tight spot in this bearing here. You would think there would be a tight spot all around there, but there seems to be just in one spot, so I guess I could say that that bearing is damaged in there already. Now, to get that bearing out, that was another problem too, because the bearings are knocked in that way, but if you look down, can you see? No, you can't. Silly me. You can see. That's not the outside diameter of the bearing, because there's a wall it goes up to the bearing, so it can't fall out. So I have to go and drill holes in there. This is a big job. It's a huge job to do this, because to drill through there, okay, I've got to knock the bearings out, but I can't do that. Can't knock the bearings out because I'll lose them. So it's just hard to get people to do good work these days for you. And that's why you end up with crap heaps like you do here. They charge you $1 million and you get you nothing done. Even the welds on here. I don't know if you can see that. I'll just bring it up. I'll zoom in a little bit. You can see it. You know, weld that on. Look at it, the grinding marks. Actually, I'm pretty disappointed. One weld does it all? No, it doesn't. It should have been V'd out and fully welded up here. Probably find that this one here, the other one here, is the one that's bending, will be cracked down here. Anyway, I've got a little job I've got to do. First job ever. And I said to my wife, it's going to be the first job ever, we're doing it. I've got a little bit of this Teflon, I don't know what it is. I've got to make up a little bush for a job for her. I don't know if I'll be able to do it. Will it chatter even under this loading? We'll find out. I'll give it a go and I'll film that later and see what happens. Okay, catch you. Okay, as promised, I going to machine up this little bit of plastic. I've already made it and already made one, so this is the second one, and I'm just following suit on this, how I done the first one. It seemed to work out alright. And as I do this, I'll show you some of the other problems that we have with the lathe. So we've got a lot of little work, lots of work to do before we get it up to what I call good enough to do any type of work. But at least we're getting there, and we're slowly getting there. You probably could see I made up this little thing here. That's the locking clamp, if you remember. All I have to do is go and glue that. I'll do that shortly, and that works magnificently. I could probably show you how that works right now before I start work. Alright, fair enough, I'll give in. Where did that? Okay, has this little bit of steel which fits into there, which in turn goes into there. But what happens is, I usually set up. Now what happens, this little bit of this groove here, the round piece of steel sits, it's the same diameter as that width of that that thing there. So I do that, and I've got what's called a cushioning spring up inside that hole I've got inside the bolt hole. And then I wind this down. Okay, that stops it from turning. And if I want to lock it, all I have to do is just put a little bit of pressure on like that, and then if I want to even lock it even more, I just get a span on there and tighten that into position, and it will never move. But I don't know if you can see with that, there's a little bit of play in the tailstock. I don't know if that was from, I would say that could have been from manufacture. Hard to say. I'll do that now. It makes a bit of a noise. I just hope you can hear. This is its fastest speed. So speed, that's top speed of the machine. Of course, you don't grab the squawk and remove it out there. You stop the machine. Move that out of the road. Next process is to put a drill hole in there. I always center drill everything. It tells you the truth, otherwise you could break a drill. Because if it's not center, you've got a problem. And I'll bring you in closer. Now the next problem I've got with this lathe is probably because due to this tube here, by the way, that is pretty hot up that end. Started. Watch your back, Mrs. Long. And when I bring the material, the center drill up to this point here. Can you see that little point out there? See that there? See that there? That is how much off-center the centerpiece or this tailstock is to there. So what I have tried to do is I get it loose. And I put a spacer it's under the front here. And I push it in. I won't be able to do this with steel, so I've got a problem. Whenever you're working around a lathe, changing tools and all, it's best to turn it off. My wife is going to wash the dog now. He's just been down to the beach. Can we see him? We'll get this around, we'll go and take a photo of the dog. Yarracoon gets his wash after being in the salt water. He goes every Saturday. I didn't go down with him this morning because I was doing this video. But we usually all go down together. He's a bit of a water baby. Today he went for a swim. We don't push him anymore. He just goes if he wants to go. If it's too cold, he won't go. He's a bit of a fussy bugger. The thing, swap the tool over. But because it's got discrepancy on the centre, I have to use a smaller size drill. The finished size drill I should be putting through is 8mm, but I'm putting a 7.5mm drill through it. This packing piece under. Probably not making any sense to everybody here what's going on, but I'll tell you now. If you're here doing this operation, you understand what's going on. Now what I've got to be careful of is that I don't make the diameter too big, otherwise there's slop in the hole. So
Subscribe for more content.